Hello guys, in this video I will briefly introduce my tool changes, auto tool changes box, this one, and the operations and the process. And here is my older machine that is German made older machine, and I add the dust cover on X, Y, and as well as Z. The original machine having this is DIY one, you can see here. And this toolbox, and inside there are motors, two motors to operate it by DC voltage electricities, and one large motor is this one, 500 series, the DC motor is for operating the collar to attach on the spindle. And another small motor, 300 series I think, is for operating the cover door. And this is the power supply. This is power supply for it right here. And you can see the whole picture. This is my machine shop, very small. This is the injection molding machine. And before this small machine, after this small machine, I built my DIY milling machine here, larger one. So right here, you can refer to my previous video for it. It's already finished and run for some times. And after finish the bigger machines, now I go back to my old machines and do some revision on my memory and got everything, you can say, the retrofitted them and put them back together. Now I introduce it in this video. And it's operated in Mach3 software, and the interface I use is here. This is a 6-axis interface. At that time I was download from web. It was developed by this guy. At that time it's free downloaded, Robot Factory. It's quite good. It's quite good interface. And up to here there are 7 screen pages, and the last two one is done by me. I added. And here is the tool changer, and I'll briefly explain this first before the operation. There are 5 pockets, and here is 5 buttons. Now the lamp is turned on here. It represents the last times I make the tool changes is number 4. Maybe I already change the tools on the pocket. And this lamp here represents the pocket having the tool there. That means actually this lamp should be this. I manually change it afterwards. This represents, maybe I open the door first. Here is the door operation. You can see when I touch it. Before I swap the tool there, and I put a white cardboard here to hide something because I don't want to disclose my design. And I press this button again and it will close, but the operation is not very small in close motion, in close operation. Okay, here you can see the LED indication. Here this lamp represents the last tool change operation is here, number 4 pocket, and this pocket sense there is sensor there. It represents there is no tools there already installed on the spindle, and the rest is later on. So if I press either these 4 buttons, it will go ahead the 2 changes, and I explain others. Skip to high set. This button is for, if I press it, this will turn on. Then after 2 changes, it will no longer. After 2 changes, it will not continue to go to the tool setter for reset head to offset operation. But if I don't touch this, it will have additional operation. And here too, this tool value is also important. This is the toolbox center position. It represents this position. Whenever I turn on the machine, I need to home it. It will home at the 0 point around at the back of it. So here is minus 300 something, and in y direction is plus something, and the rest is not important. Is for the touch pop use. So I will demonstrate it. And additionally, I already set this fixture number 1 position. This position is 0. It's almost 0, 0, 0, and negative, and this is all of them are almost zeros. And now I start to 2 changes. On this, I select number 3, this one. I hit this button. And for the other programs codes, I will explain later. I hit this. The door open. And as there are tools are already on the spindle, it will firstly detach it on the empty pocket first. Later on, you will pick up these tools. I will take out the paper. I will not show it. So it's now going down, and we'll turn on the motor. To unlock it, and then it will rise up again. So there you should know the collar and the tools already insert to the pocket. And you can see here this number 3 light is turned on, and so we picked up the tools, and we'll go to tool sensor. And also it will, at the touch point, when you close the door, it will turn the DRO to 0 and rise up to the uppermost position is 25, and the Z offset was value is entered to the Z DRO, and it will go back to the original position, but the Z position is still at the uppermost location. That's the end of the operation. And you can see here the lamps representers. Here is the existing tools position, and this is empty. In order to execute the operation, I need some program, and the required program for running the tool changes. Here they are stored in here. The Mach3, Mach3. First is M6 start. The next is M6 end, and as well there are one written by me, M9999, and whenever I hit this button, and the VB script inside this button has the macro code for the M6T something, then it will call this file start, and here no need to see others. It will, there are code line here. It will call the file 99999. There is this one, and afterwards, after running this file, a long file, it will end, and it will come to this M6N. There is nothing. That's it. It doesn't need to do anything, just end it up. So this long file need to be written line by line, line of code, by line of code. And here is the standard code lines. So the selected tool is number is entered into this tool variable. And there is some definition of the variable and constant. And this is the offset. The current fixture is G154 or fixture 1. The offset value is stored in this DRO. They are put into this variable, and this offset value are used to for this DRO use. They are this one, tool number 1 and to tool number 5. There is the pocket number 1 to pocket number 5, the XY coordinate. And this TP is the tool offset setter position, X, Y, Z. And this CX, CY, CZ was used to store this value. It is a position of the toolbox. This value is the EZ travel distance. And then go to this, the current position of the tools. These three values are stored in the OXC, Y, Z. And the first part of the program is to check the current condition of the 5 pocket to see which one is filled or which one is not filled. There is which one is empty. There is the tools already installed on the spindle. If there is one, there is the one, for example, number 3, then S will be, then the pocket will be empty and the sensor no sensing on there on it. So this LED is 0 and the S is set to number 3 that marks the tool number field was installed on the spindle. After checking, we go to selection, case S. For case 1, if we hit the choose tool button is also 1 and the empty pocket is also 1, then it represents our request tool was already in spindle, so no need to already your designated tool, so no need to anything and end up. Otherwise, we do the rest. Here the mean is succeed. You don't need to close the door. and then go to the next cycle for new tools. Then here is the next portion of the program. Select the tools, select. If case 1 is select, then check again if the tool pocket is filled. Then load the value into this new variable. Slow down the feed. This one is something different. I skip it first. Go to tool number 2's, case 2. Then it will this call motor fun, and load down the tools. Go to reset new and unlock. This will is wrong. It should be called this will lock the collar into the spindle, and then rise up and see if the pocket is empty. That means it is correct. This extra line, cook line, is reverse the motor a short time to release if gear is locked up. This is additional motion. And go to the important part is the reset sense. Then after picking tools, it will go to reset tool setter for checking reset offset value. Afterwards, it go back to here and close the door and go back to the original position of the spindle head position, while this XY position, the reset position should be at the uppermost location. And go back to case 1. I have some additional selection for case 1. If the case pocket 1 is inserted with the touch pop, then there is 2 selection. A pop out message for select if it's now for choosing the cutting tool or choosing the touch pop. And I will not continue this, and I will in next video talk about the touch pop. Then I'll go to the tool sense, reset head, offset, checking. And here, this portion will be the subroutine for the reset sense. And here is position of the tool setter. And go to the XY reset position and see if the is in open state. This part of program is, you can find them in the other website. They are similar for popping. Feed down, slow feed, and if after a certain travel it's still not touched, then it will have a message to input more distance D to go down. So if it touch, it will move back higher position by 3mm, and then go on fit down slope, but in slower fit rate, this way. And to this distance, go further down by -6mm. Of course, if it hit the G and call this G code, it will go down to check. Once it touch, it will stop and have the value stored here, and this line will move back to hitting point in case there will overshoot. So move back a little bit. Z will move back a little bit. Here, move back to this value, and the value is stored into this variable, and this value will be stored into the ZDRO. And then the Z will move to the uppermost position. This will compensate the offset value. And then restore the current fit. That will end up all the program for the tool changes. And for this screen, I need to do this screen pages, and in Mach3, there is some download on the disk file screen 4, and there is screen 4 operation, this program. After hitting it, already done this, it will come out hit this screen, and you need to open the original screen file. This is 6-axis. After opening it, the screen is like this, and you can do any modification on it. For the original one, you can do any modification on the original one of this guy that made, but I haven't. I add these pages. So there is a list of functions you can select: DRO button, LED lamp. This DRO, you add this, and this LED. For example, this LED, you need, after added, you need to go to this page and then have entered some 1000 something digits for this to assign to this LED and function. There is some menu to explain it. And for the button, this is the VB script function. So we need to do it in Mach3 Mach3 VB. And for I first explain this, there are 5 LED. They are censored from the toolbox. They are output from this here. Have the sensor here. As in, when I go back to the Mach3, here Mach3 config port and pin input. Here OEM number 3, 4, 5, 6, 7. These 5 pieces is the 5 sensor, and the port and pin are under here. And afterwards, I need to go to this system hotkey and then assign trigger number 3, 4, 5, 6, 7. These 5 pieces have a number about 1000. I assign this value, so it come out to this value 1303 and go to 07. So in the against, I need to do some more things in the VB script editor or VB button script. When I hit, here is the Mach3 pages, not the screen 4. Then I will edit this button. When I hit this, then I need to write this code on it. So if not get OEM LED, this OEM LED is here to 1074 is here. There's 5 LED. Then whenever I hit this, these 2 value will be 1. This LED will be 1, DRO will be 1, the rest will be 0. When I hit again, it will turn back to all of them 0. There is this function. And go back to the, and one more thing, there's some tricky. Another thing is you need to go to brain control here, and I write the file here is the brain OEM trigger, this one. And when I go to brain editor and then open this file, brain OEM trigger, of course you need to make a new file and then do all this stuff here. The purpose of this is to link up the OEM trigger number 1. That is the button number 1 to button number 1 is this OEM trigger 3 to 7. This 5 button. Link up this no operation path signal and then go to OEM LED 1303, so that after linking this up, then this LED will sense the input signal from it, otherwise no operation can be seen here. And there's almost there. I think I have included all of the stuff. And here is next page, pop for popping. Next video maybe I will do the popping, and you can see in my last video I have introduced my touch pop, and it can be installed here on the first pocket. And this I do it quite for fun, because in mechanical I need to do many things, and I done it around 6 years ago. And before this I used these machines, do a lot of milling operations to make the injection mold. You can see this injection molding machine here. And I can show here, this one is some scrapped pieces that I machined this, the core of the injection mold, and some wrong machining, so it became a scrapped pieces. And this, so I have built this 10 to 15 pieces injection molds. They are about, I think here 6 inch, some is 4 inch long. They are not a simple circular shape pieces or a bottom cover, not just a simple shaped pieces. You can see here is complicated part, and the molten material plastic can flow around here, so the machine need to higher pressure power. You can see, and clamping forces. You can see there is 20-ton car jack to do injection. And at that times I haven't done this. I haven't yet built this toolbox, and I do a lot of machining, manual tool changes. And after I build this, but I do less on this machining, so have not use it, only seldom use it. So this building is almost just for fun. If you have much machining job, or some especially for some repeatable job, just is quite useful. And if you are just sometimes used for machining, and the machining job is not complicated, then the benefit or is not so great. And making it is, for me, is just for my study and for my fun. And thank you for your watching. And that's end of this video. and you can see my whole machine shop.